Erasmus is a design research tool intended to augment a user's ability to explore technical solution spaces. When faced with complex problems, engineer designers are increasingly required to expand the breadth of their search for insights that might assist them. Optimal solutions might have been captured in academic papers from a diverse set of complex fields. Google Scholar quickly locates a set of papers relevant to a user's search, but the target knowledge contained within them can be locked behind arcane language. This model even presumes that the user knows enough to ask the right question. IBM Watson can assist engineer designers in more rapidly iterating their research questions. By quickly providing a precise answer to user questions, Watson shortens the user's search. But much of the language is still arcane to users. Identifying concepts for further exploration still requires domain expertise. Alchemy, another IBM solution, uses natural language processing methods to rapidly extract entities, keywords, and concepts from a text. It displays these results in a series of tree maps that allow users to quickly visualize the relative importance of each logical unit. But an Alchemy user must already have a single text to be parsed, and Alchemy provides no way for users to process its results into further questions. Erasmus joins the strengths of Watson and Alchemy into a single user experience. When faced with a difficult engineering design problem, an Erasmus user can quickly seek answers both within and between foreign disciplines, without becoming an expert in each of the relevant fields. Users can quickly explore a concept space at a high level of abstraction, beginning with a single question about, for instance, why some birds are able to survive on seawater. Behind the scenes, Erasmus generates variations on the user's question, developing a map of the concept neighborhoods surrounding that question, then returning a visualization of the concepts embodied in IBM Watson's top answers. Consider, for example, Brian. Brian's an engineering designer who's interested in improving desalination techniques. Brian feels that the desalination techniques used by seabirds hold key insights into the problem, yet he knows very little about how this process works. He does, however, know that water, birds, and desalination are central to the concept space that he'd like to explore, but he has no expertise in fluid mechanics, biology, or chemistry. So, to begin, he asks a simple question: how do seabirds desalinate water? Behind the scenes, Erasmus expands on this question, generating variations to better represent the concept neighborhood, then returns a collection of concepts associated with the answers. Now Brian can see more of the concept space related to these three initial components. What, for instance, is a salt gland? Brian's curiosity is piqued, so he asks a new question. This further expands the concept space in that direction, demonstrating new, related concepts which might assist Brian's research. After a sufficient number of questions, Brian has developed a high-level map of the concepts that occupy the area in which he's interested and the way in which these concepts are connected. With this, he's able to narrow his search to a small set of concepts that seem promising, all without developing unnecessary expertise in the disciplines that cover these areas. Erasmus addresses the needs of sophisticated and influential users who were previously left to cobble together partial solutions from an array of tools. By combining the power of Watson and Alchemy, while performing some special tricks of its own, Erasmus opens new markets filled with highly sophisticated users, many of whom are supported by large organizations with substantial budgets for investing in research and development tools.